Jason Sprague with Liebert. Going to do owner training today on the UPS system. So just to don't know everyone's background, UPS is uninterruptible power supply. Basically, we have 4 systems in here running in parallel, an A and a B side. An interruptible power supply brings utility power in, converts it from AC to DC, charging the batteries from DC back to AC, giving you a new sine wave for your equipment, your load. Upon power failure or power blips or loss of phase, the UPS will then go to battery, continuing to run your load until your generator comes on. Probably about 80 to 90% of your outages are second to 3 seconds, so your generator will never come on, and that's what the UPS does. Again, we have an A side and a B side. I don't recall which side is which. I guess in this training it doesn't really matter. We have full redundancy, double redundancy. So each UPS system, there's 2 UPSs per system. Each UPS within that system has redundancy built in, as well as redundancy as a B and a dual bus. So you have 4 modes of redundancy, which is outside of not having multiple generators, is what they call a tier 4 rating. We have battery cabinets for each system on both sides, and there's an internal bypass wraparound for each UPS. So if Liebert Services had to come and work on one UPS at a time, they can take just one down, put an internal bypass, and work on the unit itself, still having 3 tiers of redundancy for your load. Going in here, we'll go in and see if we can zoom in here. And let me show you this one more time. So if you walk up to a screen, and I just want to make sure everyone can hear me and I'm not too loud. You walk up to a screen, it will be blank, just like you see here. You can push any one of these buttons and the screen will come up. These buttons here cannot change the functionality of the UPS, so you don't have to be concerned. Again, just like here, just push the screen button, and one more time, push any one of these buttons. Back here, walking through this display, from left to right, we have our power path. So our utility coming in, and it comes in through the input of the UPS, in through what we call the inverter and rectifier. The inverter and rectifier are what cleans the power, and then out through your output. Your output then feeds your load. So when looking for normal operation, we're looking for 3 green lights in a row. Your status is always green unless this changes. And then it will go either red on alert, or if you go into bypass, it will go amber. So again, straight across, all 3 green. You know, if you do physical checks, you want to check them all, just come in and look. All 3 green is good. Coming down here to these buttons again, that will bring the screen up. And you can push the help button one time once the screen is up, and you can actually see the power flow through the UPS, which is matching this as well. Scrolling through here, you bring this up. This will be labeled unit number 2 on the A side. So down there, that unit will be unit number 1, because they're working parallel. So first screen, as you can see, the arrow coordinates with one of the buttons below. So my first screen is my input, or my main, as they call it. So you can see coming from utility, we have 118, 19, 120 coming in. So utility here is actually really good. Scrolling through, we now have our bypass voltages. So if we were to go to bypass, it synchronizes these bypass voltages with the input to make sure they're in sync to go to bypass. If for some reason they were never in sync, it wouldn't allow you to go to bypass. It would call out for an asynchronization error. And typically 90% of the time, you wait a second and then it becomes in sync. It just depends if you have a generator running in the building or something's going on, but it will tell you that. Again, my arrow coordinates with a push button down below. So I'm going to go to now my output. Now my output across, this is what's feeding your load. And this is voltages and current. So we've got 100 and let's call it 9 amps on feeding the load on this UPS. Coming here, kVA and kW. Those are terms, volts times amps equals watts.
We're engineers here.
Okay, all right, I didn't know my crowd. Thank you. All right, so what we look at is your kVA and your kW. Your kVA is your kW is your true power draw. So we look here, and we're actually at unity. So our kVA and our kW should always equal. A lot of times you'll have a power factor correction. These boxes don't have that. They don't need it. They're unity power factor. So our load level, 43%, 43%. Now I want to take you down to this unit real quick. And again, I'm going to scroll through the coordinated button. The load. So these should always be matching. So because they're sharing the load, this percentage here and this percentage here should be equal. If one unit was to fail, this whole load would go to that one UPS. We'll just continue here on this one. So I'll go to my next one, which is my system. So that system is both units working together. So we have our 25 kW. And then we get into our battery. On this system, there is a monitoring, which we have. Are you monitoring with SNMP? Not yet? Okay. On this system, we have, we monitor our battery temperature, our float voltage. On the monitoring system, when you have it remotely, it will tell you how much runtime you have. On this screen, until it goes to battery, it will not tell you until it goes to battery how much runtime there is. But you can go on, again, like I said, onto that SNMP when we give it an IP address, and it will tell you how much runtime. And I can calculate this based upon our load and our float voltage. If we need to, I can show you that calculation after we're done. But again, the SNMP card, which is right here. So once we have that programmed, we'll be able to plug into your network.
These were supposed to have both the SNMP, the Ethernet, and also the
Modbus?
Modbus.
Yep.
Remember?
Yeah, this is a Unity card.
Yeah.
So it has that ability. So Modbus typically is a 4-pin connector. So they have a RJ45 connector adapters for 4-pin. So because this is a Unity card, it can do actually Modbus, BACnet IP, SNMP.
We're going to need some instruction on how to hook all that up, because we got the wiring in here.
You do have it?
Yeah.
Okay. While we have this door open, the most important thing on this training is these site ID and tags. So if anything were to alarm, if you have a funny feeling and everything looks normal, you call 1-800-LIEBERT. Okay. They used to have a number on there. It would make sense, right? It's 1-800-LIEBERT. LIEBERT. and you give them this side ID and tag, first thing that they do is send you to a technician, a technical person, to walk you through what's going on in the room. If they deem necessary an issue, they will then dispatch a technician. So we have a 4-hour guaranteed on-site response time. We have a technician, our closest one is in Naples now, and we have 4 up in Tampa. So it's a guaranteed, again, 4-hour response time. We have all these parts, they carry all these parts in their truck. If for some reason it's a board or something and we don't carry, then it's in Orlando. So 99% of the time we have it resolved that same day. So again, your site ID, which distinguishes this building, and this tag is for this unit. So if it's one of these units or any one of these units, and once you call that 1-800-LIEBERT number, they'll ask you, that's the first thing they ask you, is that site ID and tag number. And they can pull it up in their system, they can see it. While we're also in here, our nameplate. This is per unit. This just gives you your input, your output voltages. You know, if you ever go third party on service, this is the information they'll want to see. They want to know what the unit is, input voltages, output voltages, amperage capacities, that type of thing. And we can talk about that offline. You mind? So the battery cabinet, let's look at this one so we know it's not as loud. The system has a battery cabinet. It's obviously for arc flash protection. It's double dead fronted, so we can't get in and look at the batteries. If a UPS was to fail, or if you push the EPO button, which I'm going to go over, this breaker will then trip. This breaker will take the availability of DC power or battery backup off of that UPS. So again, if there's a DC fault current, a fault on this, or we go over temperature, there's a number of different variables that will happen where this will trip. In this system, when we are system, both will trip on a DC fault current or an EPO button. Temperature, they won't. So basically, if you came up and you pushed this EPO button there, and do you have one on the wall? Okay. And we'll go over that. These two breakers would trip, and the input breaker would trip. This system would go down. This unit and this unit. If you push either one of those red buttons. And again, the same on this system. So this, we'll call this A. We'll call this system A. We'll call this system B for now. So if I walked up and I pushed that EPO button, both of these will go down. So again, this is your DC breaker. This
will it go into bypass?
It will not go to bypass. Your output and your input breakers will trip. And
so that everything supplied by these will go down.
Correct. And that's an emergency power off situation where it's on fire or something's going on where you deem as an emergency and you want to take that responsibility of pushing that button. Make sense? Okay. This cabinet is tied into that site ID and tag. So when they pull up that site ID and tag, they'll see the UPS and the battery cabinet. We'll go back down here. It's just a little less. System having an internal bypass as well. So these act, and I'll go over this after. This internal bypass is a Kurt key system. So you can't shut this load off on accident. You physically have to come in here. Oh, I'm sorry. And put this into bypass. And the way we do that is, and I'm not going to demonstrate it other than showing. Right now our inverter and rectifier are on. They're being used. So if I came in here and I pushed inverter off, right here, inverter off button, At that point, it will go out and it will sense the bypass voltage, make sure it's in sync, and then it will send this unit into bypass. So your power path then will be here. So your input and your inverter are gone. Now your power path comes through this way, bypassing all of that. At that point, this light will light up. This is a solenoid. So you cannot turn this key until that light lights up and you push that button. So once that's done, you pull that key out and you put it in there, and then you can close that breaker and open that breaker. I'm sorry. You go and let me correct that. You close that breaker and open that breaker. At that point, your load is now not on any of these modules. So they can come in here and they can actually flip the switch, unscrew it, and pull this module out. This is the whole inverter bypass, or the whole inverter module itself, which you have redundancy built in. So as you can see, there's only very few components to this system. You have your inverter rectifier module, your static bypass module. So if any one of those had to be replaced, that's something they grab off the van and put it back in, you're back up and running. If you break a breaker, that's obviously something, you gotta really kick those and do something bad to break those breakers. And underneath this panel here, all your input and output connections. So there's no mechanical device within here. The only mechanical or working devices are here.
Bypass. The only reason
Never.
would be to repair a module, but you guys would actually do that.
Yeah. As far as I'm concerned, I've been doing this 16 years now. I tell my customers the same thing. Don't ever touch these units. The only button you ever need to touch is the emergency power off if there's an emergency. Otherwise, that's why I say this is the most critical thing, is the 1-800-Liebert Side ID and tag. They will then, if you need to do something, they will then walk you step by step through the process over the phone, or have somebody here within 4 hours. Here in Fort Myers, we're about an hour and a half, 2 hour lead time to get here, typically. Unless we have 5 other emergencies. Then we pull somebody from Miami or Orlando. So again, just to recap, this is System A, Unit 1, Unit 2, acting as parallel, what we call parallel redundant. So right now, they're sharing the load. If one system was to fail, this system would then take the whole load. And that's just on the A side. And maybe you can, I just don't recall. You want me to wait? Go out, we're going to start all over. No. So everything I've shown you on these two systems, identical mirror image over here. Again, your A panel and your B panel for your load are out here. And then out from here it distributes, if there are any IT loads, I'm sure that most of it is dual corded. I don't know how on your distribution you are. If you're feeding one section of somewhere with this panel and another section with that panel.
Yeah, basically this is that side of the
Okay.
building.
Okay. All right. So that kind of covers the UPS. Again, what's the most important thing? Side ID and tag. Yep. Now I want to go over the overhead input and output, which is a complete wraparound system. So if they ever had to have a major malfunction, a bus failure, a fire, something within one of these UPSs, and they have to pull this UPS out and replace the whole thing, then what we have the ability to do is go into what we call a wraparound bypass, wraps around the whole UPS system and still feeds power over to your panel. And again, that's worst case scenario, 16 years, I've never had to do that before, but we build it in for Tier 4. So above here, we have our input and output, what we call bus duct. Basically, these are 400 amp. This is 800 amp bus with 400 amp input and outputs. So once the system either was EPO'd or put into bypass completely, because, and this is critical, and again, you won't ever have to do this. This is for Liebert or excuse me, third-party service. Basically, once these are all put into bypass or EPO'd, you have no power path into these, because we don't want to synchronize the output of a UPS with the output of your utility, because one's clean and one's not. By code, we got to have chains. You got to hang on these to pull this breaker, just so you understand. Not literally hang, but you can't bump into it and it trips. So again, each one of these is a shunt trip plug breaker within this can, and this is just 400 amp bus. You know, large cable. As you can see how large the pipes are. So you have our and you can record this right now, and it's something that Dan and I are working on. These have to be labeled, input and output, and we have that, and we're gonna complete that. So right now, our input, we're in bypass. So I would come over here to this one, and I would pull this breaker. At that point, that opens up our output. Once that's done, then we have. No, I'm sorry. Let me reverse that. I gotta, because they're not labeled. I gotta remember. So this is our input, and this is our output. So we open up this breaker, this one, and this one. That now opens our breakers for our output. At that time, when these are in bypass, at that time, we have wrapped around this system. These are the input. These will never get pulled unless an emergency. Again, these will always feed. These are feeding the power of the units. Once we have these pulled, then we're wrapped around. We're wrapped around the unit, and we're feeding out to into the wraparound bypass panels. And again, I'm gonna put this on camera, and I'm glad none of you came in here. I'm actually gonna ask you to stay out there. So basically, this is our output here. So we've wrapped it around by pulling the chain, and we close these breakers. That will then put the load from the UPS back to those panels. And again, this is, you won't ever touch this. This is again a Liebert or a third-party electrician, arc flash. Stay away, don't open. And it's identical in this one. Kill the inputs of these and pull them out completely and replace them. So if only one system went down, so let's say in 20 years we come to end of life, 25 years end of life of the UPS system, technology changes, you guys understand that, and we want to pull these out. In 20 years they're probably going to be about this big. We can do that without ever taking down the load, essentially. That's the other thing, other than an emergency, why we put the wraparound system in. So again, to recap, 1-800-LIEBERT, L-I-E-B-E-R-T. I'll look on my phone later and tell you what those numbers are. And give them the site ID and tag. Site ID, tag number. And this is a system, and it's associated, all these are associated with this one number. It's all the same on all the units. So you could pull open any one of these. Again, I would recommend writing this down, putting it in your Outlook contact under Liebert service with the site ID and tag, so you can just call from there and you don't have to go in. Again, we'll if you have the network drops here,
I think they're coiled up right on the backside.
Okay. So we can, if you wanted to test it today, how long is your service coil?
It should get out, yeah, to any unit.
Okay. If you wanted to,
How many of these do we have to have hooked up?
I'm going to just reiterate that question one more time for the camera. The question was, if we lose utility power, how can we tell on these UPS systems? Number one, they'll beep. And like I said earlier, most of your power outages are 3 seconds. If they're longer than 3 seconds, your ATS kicks over to generator within 10 seconds, you said? So you only hear them if you're walking by beeping. You'll get, once we have the communications up and running, you'll get email alerts, notifications that you just went on to battery. And then once it clears off the battery, once the generator comes on, it'll go back on to normal, it'll say normal power. So this will beep. You will see a red or an amber light on this box right here. There's a designation for the batteries. So that will come on and this will be off. So this first light will be off, this light will then be on. And it will be beeping. I'm going to show you this as well. And at that point, you can run through here. You can go to battery. And while it's on battery, it will come up and it will tell you how long you have runtime, which you're not going to need because your generator will come on. But it will tell you how long you have until the batteries are depleted. In this case, we'll have, I think we got 15 or 16 minutes, which we won't ever use. And then, or you can always push the help button. Whoops. Let me show you one more time. See where it says flow underneath? Again, they line up. So flow, again, you see the power path moving. You would see it coming out, not here. This would be look like this, solid, and it'd be coming out like that. Again, beeping. To clear, the only button that you can touch over here, or you can touch any button that belongs to you, but the only button I recommend that you touch over here is your silent. So if it's beeping, it's annoying, you can hit silent, and it will shut the alarm off.